My name is Pieter Houtekamer. I'm working as a senior scientist at Environment and Climate Change of Canada, and I'm responsible for the development of the Ensemble systems. So I've set up medium-range ensemble prediction system, and more recently I added a data assimilation component there, and I developed an ensemble common filter to provide an initial estimate of the uncertainty. So in Canada, we use ensemble forecasts for all forecasts beyond day 5, because there is a lot of uncertainty in forecasts beyond day 5. So you wouldn't want to issue, say, a monthly forecast without giving some indication of the reliability of the forecast. So the ensembles are used there. And also ensembles are used in an automatic fashion in data simulation. So there we can see from the ensembles how the uncertainty in our background estimate spreads out in space, so that we can make optimal use of observations to correct in these directions. In between day 0 and 5, say, we make use of ensembles for extreme events. Extreme events in Canada, that's often something like freezing rain or snow or something involving precipitation. Then we want to know what's the reliability of our forecast, and should we really be warning people. I think when we set this up initially, the ensemble forecasting was done by a very small number of people who were added to the weather service to give predictions of uncertainty. So they came up with simple add-on procedures that could be added to the numerical weather prediction exercise. I think what we need is a more of an integrated approach, where the entire numerical weather prediction center is working together to describe uncertainty. So people in model physics, they would think about what's uncertain in the physics of the model, and then they would tell ensemble prediction people, there is uncertainty here, please sample this and see for us how this evolves in time. So then the result would be a prediction of uncertainty of error distributions in the future that maybe can feed back to these modelers, and they could try to improve their systems. So I think we need more integration between model development, data simulation development, description of surface fields, ocean models. We should couple everything together and try to have a coherent description of evolution of errors in our systems. So currently, for the medium range beyond day 5, all the forecasts that go out are based on the ensemble forecast, because when you go beyond a week, the forecast scale is quite limited. So then you cannot rely on a single deterministic forecast, because it will likely be way off. So you need to have many members so that you can see what remains as being predictable. So for long range, the good use is made of ensemble forecast. Also in the very short range, when we do data simulation, we have automated systems that are able to see, well, now we have uncertainty in certain directions. So we can make then an optimal use of observations to correct our estimates in these directions. So in all of our data simulation, we're now using ensembles to make the best possible use of observations. And then there is an intermediate stage, say between day 0 and 5, where ensembles are used mostly when something very important happens. So when there is severe events that we predict, and that can be freezing rain or snow, and then forecasters, they will look, no, this is a severe event, we would like to know what's the uncertainty before we take action and issue warnings. So you can see same, for instance, with hurricane forecasts, these are very dramatic events. So you really want to know what's the range of possibilities before you take action. So there, ensembles are very important.